Welcome back to Hacker Hangouts. We are now live, and I am excited because we're jumping into machine learning, artificial intelligence, but really we want to get into the meat and potatoes of the matter. Like, I actually will just call it the intriguing pieces, which are like the cybersecurity ramifications, and both on the vulnerability standpoint and then like how to impact these type of systems because they're becoming more and more frequently. And in some pieces, I have like a guttural reaction when I hear there's this new AI system which is going to prevent zero-day attacks, which I've heard multiple times. Microsoft is one, but theirs is kind of on an interesting piece, which I want to get to. But let's cover some of the boring stuff first. It's like the best thing to do within a video is like, let's bore people to death for the first minute with like, what is artificial intelligence? What is machine deep learning? Because they're kind of like inner pieces together. But let's just get the boring stuff out of the way so we can get to like fun stuff like Kill Decision and Daniel Suarez and like the cool stuff of like being able to manipulate hundreds of thousands of people. And that's because that's the goal of AI. Gowrie, can you kick us off with just what is machine learning? What is deep learning?
Sure. And don't worry, for the viewers out there, we are going to talk about autonomous vehicles as well, because that's the most obvious impression, for obvious one that we can talk about. So let's talk about what AI and machine learning is, because they are different, right? And people group them together, but it's important to understand the difference. AI is a reasoning system, right? That's the basis of it. That can come in many different forms. It can use a many different set of subsystems that include handwritten stuff or models that were generated with machine learning. So what is machine learning in that regard? Machine learning is actually pretty simple to understand. In traditional programming, we create programs that have logic that operate on data and produce some form of output. That output could be another set of data, or that output could be some reaction to something where like a robot arm lifts something up, right? So traditional programming produces some form of output or reaction. Machine learning is taking some amount of output or data and a number of sources of data and producing a model which can be used by a program to produce that output or reaction, which I know sounds very confusing, but basically all you need to understand is that traditional programming, you write the program, and in machine learning, you have a program that produces a program, or a model that can be utilized by a program to make decisions. And so AI can leverage machine learning models, the output of a machine learning session, to create decision trees, or automate the creation of decision trees if you want to do that. And so deep machine learning, you'll hear that term a lot. Deep machine learning is using some multiple layers of ML, or maybe a collection of various ML models to create decision trees and then push towards that idea of an AI. And AI is, in the traditional sense, people like to think of AIs in terms of what was that Person of Interest, right? It was a television show where you had this AI that made a bunch of decisions, specifically trying to prevent bad things, like this massive reasoning system. In reality, AIs are not that. That's a general intelligence, and we can debate on whether or not we'll get there, but that's not really the point of this stream. But the reality of AIs today is that they're hyper specialized, right? Mm-hmm. You have a specific thing that you want an AI to do, and then you create machine learning models that help you support that reasoning system. And one of the most obvious ones is an autonomous car, right? So we want a car to be able to drive down the road, obey all the laws, all of the signs on the road, deal with anomalies, and not run over puppies and kittens, right? Like that would be the goal, and then ultimately make the roads safer, because you run into issues where, what if somebody has a medical emergency while driving? It would be nice if the car could take over. And there's different layers of that. So that's the basic idea. So if you take nothing else away from the stream, just take away the fact that machine learning is a program that produces a program that can be utilized to make decisions, right? And I think we're going to jump over to Gulo.
So, as an actual real world example, I used to work for a value added service provider. Basically, they pimped me out to all these companies all over the place, and so I worked with dozens and dozens of companies. And it was around the time that ransomware first started to come out. So, I play with evolutionary algorithms, EAs, and I use those for all kinds of things. I use them for stock trading. I use them for world domination, and I took some of those for to put against this ransomware. And so all these companies kept getting hit with ransomware. It kept encrypting all of these files all across their network, all across all their servers. And the solution was to restore from backup. Restoring an entire server from backup, you can lose a crap ton of data, and it takes forever. So I started looking at the magic byte of files. And the magic bytes is, in Linux terms, is what the actual file type is, what the MIME type is, whether it's an executable, an image, a sound, a movie, whatever. And it's usually the first byte of the file will determine what that is. And I found that ransomware, depending on the version you were hit with, set the magic byte to be the same for that particular version of ransomware. So I took some of my libraries and I applied them to file servers, and I started to search every file and process through and pull that magic byte out. And then I was able to identify every single individual file that was actually encrypted. And I set this loose, and whenever it continually found, so I fed it data of all of this is encrypted data, all of these are Word documents, all of these are Excel documents, and it went through and it was able to identify when someone was hit with ransomware. I was able to do things like shut down networks, disable file permissions, all kinds of other background scripts. But I also did it for companies that were already hit, and I would tie it back into their backup solution. So I would restore all of the files that were specifically encrypted and not just the entire server and wipe everything out. And this was, in machine learning language, this is, I was taking vast amounts of data as a human. I couldn't process any decent amount of time, but the programs that I wrote, the libraries that I used, were able to process the data and spit out information and spit out the models I needed to identify very specific sets of information. And this saved, I mean, when you're dealing with hundreds of thousands or millions of files across disparate networks, it's not something a human can go through and actually do in any decent amount of time other than decades. So by setting this loose, I was able to save companies a lot of time, a lot of money, and it was a very practical use for machine learning at the time.
And so go ahead.
I was going to say, it sounds like this scenario though wasn't really consuming lots of data. So like as I understand, there's really two major pieces of machine learning. There is predictive, which is I want to take all of this data, I want to plot it, and then I want to find, we'll say like the algorithm, which is able to predict. I want to map all of this out, and I want to do predictive analysis of where am I going next. And like a good example of this is like a stock trader. Things like this is when I'm going to have all of my data go out and scrape websites and find what is the frequency of the website changing for this company. I'm going to plot it on the graph, and then when I see increase changing, what does the price do, and start building out a model that way. And then there is so the other one is like the comprehensive, or what is it called? Predictive, and I lost my classification. There we go. Prediction and then classification. The classification is kind of where like that one's more relevant in cybersecurity. Is I want to make baselines, and this is like where Microsoft is going with its, what they call it, AI or machine learning, but they have a much bigger thing. But you want to like create sets of data for your users. So your set of data is, I want to take all of their logins that they've ever had across all time, and I want to then make my model off of that and say, okay, typically they're logging in between this time and this time within these geographic locations. When I see a deviation off that, then all of a sudden we want to flag it. And this is what Microsoft is claiming, like for machine learning and artificial intelligence, because they have a very big data set across all of Office 365. And that's the classification aspect. And that's where it becomes really interesting from a cybersecurity perspective. Doing more like event monitoring and Gowrie might even be able to talk about some of this. Is that being done with on the system layer? For instance, like these DLLs are always calling these things, and all of a sudden now when there's a deviation from that, like this is where we start going into this like part which feels like snake oil, because people say we can predict all the vulnerabilities and capture 0-day threats using our artificial intelligence.
Yeah. So put bluntly, if you ever hear the phrase AIML and 0-day threat in the same sentence, that's snake oil. Period. The end. No, like it doesn't mean anything, because like you have to define very specifically what 0-day threat means. Right? Are they talking about someone actively throwing a packet into your network that is, outside your base normal, quote unquote? Or are you talking about analyzing a program and finding a vulnerability that hasn't been discovered by someone yet? Like there's, are you trying to detect someone utilizing a 0-day vulnerability that has been discovered, obviously by someone but not disclosed, or are we trying to find the vulnerabilities within the program? And so that's why you need to like, when you see those two phrases in the same sentence, you should cock your head to the side and be like, what does this thing actually do?
This is where right before we go to Gulo is like, but this is where 0-day threat is so funny to me, because I actually think, again, I agree with you, it's snake oil for a lot of it, but the term 0-day might just be like, okay, you guessed the password and logged in, like that's a 0-day threat, like in like using that analogy of like Microsoft can claim it because when someone tries to log in from like some China or wherever, and they're typically out of like Michigan, all of a sudden, like that's a 0-day threat because the term is kind of squishy.
So this is the difference between identifying anomalies. Wow. It's the difference between finding anomalies in your network, something that deviates from the baseline. So you now have a classification system, versus finding application holes, which is more likely going to be fuzzing. And I would argue that fuzzing isn't necessarily machine learning. I mean, you can put all kinds of different, I guess you could train machine learning to create multiple different types of fuzzers and the heuristics for those fuzzers, but I think that would be a stretch. So the difference between like an antivirus and an application vulnerability testing, and an antivirus is more about heuristics. What on this system is different than what was running before? And then identifying those and processing those, and then calling those 0 days as you've now been hit with something. So baseline versus anomalies, and then you have fuzzing on the other side. So I can see 0 days as in anomalies on your network. I have this new packet, I have this new file, I have this new user, whatever it is. And I can see machine learning for those, but I don't see it necessarily for fuzzing an application.
I want to allude to something, and then I want to bring Gator in on the discussion, which is we're getting to this idea of, the original question Silk asked me was, do you see, something happening on the endpoint with antiviruses utilizing this stuff? There was this old debate, right, with regards to intrusion detection systems and intrusion prevention systems. And where we're getting into is this: when do you decide to let your intrusion thing, your thing that's detecting the events? The difference between these two things is that the intrusion detection system will detect, log, and alert, but the intrusion prevention system will actually try and shut something down. The problem with intrusion prevention systems is that if you can understand its heuristic from the outside, you can actually just effectively DDoS somebody's network by taking advantage of the fact that it's going to take, quote unquote corrective actions. And so if you can take advantage of that and know what it's doing, you can cause real damage, because you're basically, what is the term is like a trusted mate attack. I forget the term, but it's basically like, this thing's going to take an action. So you just get it to take an action against somebody else that, maybe you just shut down the corporate network because it thinks the attack is coming from inside the house, right? So from endpoint security, this is where we get into this idea of, like, Daniel Suarez has this book, Kill Decision, about an AI who is given the quote unquote kill decision, right? It's given the ability to decide whether or not to pull the trigger on a weapon. And that's kind of what we're talking about here, just in a lower stakes area. Should there be an antivirus on your system that has the quote unquote kill decision for, you running an application if it happens to detect that it's malicious? What if you actually intend to run the malicious application? Things like that, if you're doing research. So, yeah, so this is where we're going to get into the fun stuff. But I want to bring Gator in from the open source perspective because he had some interesting things he wanted to talk about.
So I will say I have very limited knowledge about ML and AI. The areas that I've looked into a little bit are having to do with like the Jetson Nano Developer Kit that you can pick up and how that relates specifically to OpenCV. And OpenCV is having to do with being able to use a camera to start utilizing and or training your own machine learning to say this is a banana, this is a car, this is a person. So you have to do that training up front. One of the things that Digital Tinkerer and I have been talking about on the Holland Network podcast, just talking about what's going on in the news, is that there's been so much data, bad data, fed into our publicly facing machine learning, especially when it comes to the closed circuit camera systems, and then having people be wrongly identified from the police side of the house, and then having those people persecuted because it wasn't them. The data was wrong. It got brought to court. They had to show their source code, and this shows that there were biases based on skin color. And it's like, whoa, roll this way back because this is wrong here. So how can we trust the people who made the initial program, right? So you have to be able to go back to see the source and how that was fed. Go ahead.
Gulo, you have something to say?
Now, yes, there's biases all over the place. So Amazon, I think it was Amazon, had the problem where they set machine learning or AI for resume processing, and they eliminated all women candidates right off the bat. And it wasn't something, I'm going to give them the benefit of the doubt, it wasn't something that they meant to do, but it was something that happened because of the data that they had. They had more male engineers than they had female engineers, and it snowballed, and it just turned into a very, very bad thing. But Gator brings up a good point for the OpenCV. So if you look at OpenCV, you can also take another leap into the deep fake, taking vast amounts of video information of people recording themselves and then overlaying somebody else's face and voice. They have to take that information, process it, and then turn it into a deep fake. So now I could be, I don't know, Barack Obama, I could be Will Smith, I could be, I don't know, Daniel Suarez. You pick anyone. I keep joking around that I'm going to set up the deep fake stuff, and we're all just going to be silk on the stream for one of these streams, and it'll be great. It'll be hilarious. But that's also have a lot of machine learning built into it to create a model very specific for altering somebody's face and voice to be someone else.
So there's a couple pieces on this. First, creating a deep fake of me, you need seed images. And so I have like a guilty thing I want to confess to, because I find it like weird and hilarious at the same time. When I've been doing thumbnails, I have to always set up a camera and do like the stupid goofy face, and I've just embraced it. Gowrie, thank you for that. You've just like had me embrace the stupid faces. But I didn't want to have to always set up my camera. So now I have like a Google Drive, which I hope will never get shared out or public, which is like happy, sad, annoyed, like, and it's just pictures of me making stupid faces, so I can just go in there and grab them. So like, if you're making a deep fake, just go to that folder and you just get all the stupid faces of me you need, or just pull them out of stream. So Gowrie, go on.
No, that's perfect. Wait, we'll just grab all the images, right? Because now when we're talking about everything being online, we're online how many weeks now? We're something like 70, 80 weeks. We're turning our heads. The information is out there. It's not hard. It just takes time now. And that's the thing that's interesting.
Gowrie said it best. They can't be blackmailed if you're proud of it. There's a couple things we talked about where I want to actually mention, because I have another story, which was the idea of this, like, you have your data and then you hose the data, which then makes all the outputs. Interesting story with the IPS. You have to make sure that you have systems allow listed or like don't block these systems, because we had a really weird one happen during a pen test one time, which was we were doing an external security assessment, and out of nowhere the internet dropped for their entire network. Like no one could get in and out. And we're like, what? Look, what did we do? We did like a Nessus scan. Like we haven't even started the pen test yet. And what it was the load balancer in front of their IPS wasn't allowed. So all the IPS wasn't seeing the external traffic. The IP address it was seeing was the load balancer, and then it ended up just blocking the load balancer. Misconfiguration aside, like this is an example of you hose the underlying data. The other thing that Gulo said, which I actually find hilarious with Amazon, he went the resume story, and the one which they're actively using machine learning, and then we'll say like, I guess, sure, artificial intelligence as well, is the Amazon recommendation in like the whole recommendation engine. So like when you buy something, you're then recommended products that other people that bought that. And here's like a perfect example. How many people have bought a blender and then all of a sudden Amazon's like, you know what you need more than just one blender? You need all the blenders.
All the blenders.
Like you buy one thing and all of a sudden you're a connoisseur of blender buying where they're giving like a zillion of them. And this is like some of the downfalls of like that recommendation engine, but machine learning AI is, we'll call it like the algorithmic anomalies. And let's tie this back to like kill decision, but it's within resumes and other things like that. All of a sudden we find these algorithmic anomalies, which are kind of scary, especially like within advertising. We talked about this TikTok, YouTube, like all of these things could connect you with the content you want to see. Like what happens when we can, this is what, oh goodness, Analytica, Cambridge Analytica, Cambridge, not Cambridge.
No.
Cambridge.
Can.
Analytica, like they started like mapping out social media using this to feed their model to be able to identify, okay, this is what these people like believe and understand and are following. Okay, well, what happens? And these are the pivotal, we'll say these are the linchpins in the their social circles. Okay, well, if we can start using information to start tweaking this person's opinion, what's the impact of it? Like that's the part which kind of starts becoming a little like terrifying.
Well,
from
a security aspect, sorry to jump in. From a security aspect, you have poisoning of data. And like Silk was talking about all of his image folders, he could go through and start changing pixels on those images to break whatever machine learning I'm doing. Now, poisoning of data is not something new, and for Amazon and suggestions for purchasing of things, I did some bad things at a company. I was writing a application for their approval process of purchasing things, and I was using Amazon as an example, but I never search for normal Amazon products when I'm building something like that. So I started looking for like inflatable sheep. I started looking for Velcro gloves. And those were the things that I built into the application, but it was on the company's Amazon account. We didn't purchase any of them. But the fact that I continually searched for all of those, I started getting calls from my boss saying, what the hell are people buying on our Amazon account? You would not believe what is on our homepage right now. And it was showing up on everyone's Amazon that was at the company because Amazon saw all of my poison data and was like, oh, these people are kind of strange. We should be suggesting all of these blow up farm animals to them and all of these other random items that shouldn't be said on stream.
Also a reason why you don't use shared accounts across everyone.
Amen.
So I'm gonna actually say that poisoning of data is not that big an issue. It is a legitimate attack. Let me say that it is a legitimate attack, but it is not the bigger issue. And the bigger issue is far more fundamental. But first, I want to address something that Taylor said in chat, which is I see a transition to a Recaptcha model across unassuming platforms to feed the learning process. Gulo's VR work today will lead to real-life obstacle avoidance tomorrow. That ship is like sailed, dude. Like that's like 10 years old. What do you think Recaptchas are? They have always been data classification and ground truth systems for large organizations like Google to have classification systems that they can build effective machine learning systems on top of. Like that has, every time you do a Recaptcha, they're not depending on you to get the answer to the question right. They're actually depending on your mouse movements and your keyboard and how you're actually interacting with the website to determine whether or not you're human. The question you answer like find all the fire hydrants in this picture is actually just you doing a mechanical Turk for them to classify an image. So yeah, that's already here, and it's been here for well over a decade, and it's in every corner of the internet already. So what I'm going to say is the data poisoning problem isn't as big as the fact that what comes out the other side of a machine learning training session is non-verifiable, right? So what we actually talk about in machine learning, or what's typically talked about in machine learning, is this classification of results as a true positive, a true negative, a false positive, or a false negative. And all of these have implications, right? False positives can mean that the wrong person gets prosecuted for a crime, and a false negative could mean an attack gets through because it wasn't classified correctly, right? And so the reason why all of these machine learning systems are assessed in this chart, this 4-way chart, is because you can't really prove what the model actually does. And that is why you run into this issue with Amazon misclassifying qualified candidates because they're women, and the law enforcement trying to leverage it for facial recognition and all of these things. That's why you create these biases, because the people who create the models have no way of truly validating that the model is doing what they expect it to do. And I have said this on stream before, breaks in security occur fundamentally when the expectation of what a program does or a model does not meet the reality of what that program or model does. I can believe that my program operates on a string safely, but that's my expectation. But the reality is it may only operate on the string safely if it is given a well-formed string. If it's given a non-null terminated string, it may buffer overflow, for example. And so I didn't check for that, which means my expectations didn't meet the reality of what I wanted the program to do. These models are unverifiable by design, because if you could verify what the model did, you fundamentally would have a program that is capable of doing what that model is doing. But the reason we're utilizing machine learning on large data sets is because we are incapable of producing that program in the first place. And so this is where you get into large debates about whether or not something like machine learning or ML is actually safe to utilize in a quote unquote kill decision scenario, as to quote Daniel Suarez. And when I say kill decision scenario, I could mean autonomous cars, right? I want my car to stop at a stop sign, and I want my car to not stop while it's going 60 miles an hour on a highway. Now, I bring both of those situations up because in recent reports, Teslas were running stop signs and experiencing phantom braking on highways because they thought they saw a stop sign. That to me, that's a kill decision. You're going to kill someone if that occurs, right? And in a sufficiently bad situation. And there's overrides in place, but there'll be a point at which it gets quote unquote good enough that people get complacent and they're going to let the car do what they expect it to make all the right decisions. And then you're going to hit that 0.001% situation where you hit a phantom braking situation and you cause a massive pileup on a highway. That's why the regulatory structure basically doesn't exist yet for these things, because we don't know how to validate it. And a lot of people don't understand that base reality, that what comes out the other side of a machine learning model is unverifiable by design. And that's where we're going to get into a lot of bad implications about its use in active security measures, if you will.
And I think the other piece here is that we have like multiple phases or waves of artificial intelligence or machine learning that we've done. I think starting off, we did like fuzzy logic, which was like ultimately like a big if then else statement, or just if else. And then you do scoring. This is like very similar to like what I programmed within Project Mariana to make sense of like this big unstructured data set and say, okay, as you come across these conditions, give it a higher score. And then as you give it a higher score, I can get more and more confident within the issue. The thing is like when we're teaching a machine, like the model to say like, hey, let's just go like really simple things that we've accomplished already is like, this is a table. We give it an image, identify what it is. Is this a table? It starts off with, let's see what other tables look like and does that match it? And that's, we're able to do that really, really well. Now, you go one step farther is this a table? Like, is this a table because it has chairs around it? Is this a table because it starts getting more contextual type information? And then the farthest one is like the abstract. Like, is this a table because it sees objects sitting on top of it? And we're not like those later two phases of like the contextual or the abstract thinking in the context. Oh, it's a table because we have chairs on. We're not like, those are like cutting edge. Like there's still tons of research being done on those. And we're really at the beginning of, is this a table because it looks like a table? And now we're looking like, you're going back to like kill decision. Like you need loads of data and you need that, the idea of that abstraction or that like situational, I'm not sure what the term is, but like the environmental like decision you need to make. Like you have to, there's too many inputs. And this is where I'll pull back to cybersecurity is with something like identifying new vulnerabilities in an application or whatnot is completely impractical, impossible with the current stuff because you need to know business logic. Like I might be able to manipulate this input, but what if it is what you see is what you get editor? Maybe that's purposefully in there and there's just too much context that you have to gather for these type of attacks. Gulo?
So I deal with evolutionary algorithms, and my foray into machine learning was using evolutionary algorithms. And what that is you set up checks and balances. You start off with a parent, and the parent makes a decision based off of some input. And based on that decision, it creates children. And then those children make decisions based off of that input, and then they create grandchildren. And then basically it creates this entire family tree, and then you set up checks and balances on there that see if the output that you're trying to achieve matches the children, grandchildren, great-grandchildren, etc. And then it starts to kill off those different parts of the family tree. It starts to prune those branches. So it'll start killing off these children, killing off these grandchildren based off the checks and balances. And yes, that's what it's called. And I really love that analogy anyways. But that's how I use evolutionary algorithms. And I also did it for like biology. So when I was trying to make highly poisonous flowers using neurotoxins, I was slowly introducing neurotoxins into the flowers that I was growing and then checking the flowers and then trying to breed things that were more and more resistant and cross-pollinating. And I just
what does this have to do with machine learning and AI though?
I was gonna say he watched all the James Bond movies and then he gathered the best ones. So he pulled from Moonraker and then that's where he went after, right?
Yeah. So, but it's machine learning in the fact that I'm taking vast amounts of data and I'm expecting X output from that data. And when I use those libraries for evolutionary algorithms to process that data, I'm expecting X output. So, and for stock trading, when I was doing it for cryptocurrencies way back in the day, it was, I want to have a positive number at the end of the day. So I took all of the trades that had happened in the past year, dump them into this machine learning algorithm and let it plot out exactly what trades would take to get the most out of it. And I continually fed in more and more information until it hit the live market. And then I let it process against that live market for a while to see what the outputs would be. And that was taking vast amounts of data that I couldn't process and then using the whole evolutionary algorithms, so parents, children, grandchildren, etc., to identify the best path forward for me to take. It's something to agree with Gowrie. We can't know what the outputs are actually going to be. The same thing with biology. I can start mixing and matching different plants, different animals together and trying to breed those, but I'm going to get spurious, anomalous whatevers at the end that I either have to trim out or I have to embrace and be like, okay, this was a dead end, or I need to move down this path.
So what I'm trying to look at going and moving forward at this point is not all machine learning is bad, not all machine learning is good. How can we actually make sure that we're going through and utilizing it the best way that we can? I know personally, I'm getting ready to move to a new home. I've thought about setting up like a home assistant with cameras that have quote unquote AI, which is just machine learning for tracking a car versus a person. So if it sees a car, it'll email me saying, "Hey, this car drove into the driveway," versus, "Hey, a person is walking into the driveway." So that's something simply that I'm trying to go through and do, so I know what is or isn't on the property. What are other ways that you guys are trying to use machine learning or looking forward to using machine learning?
So using the OpenCV, you can set up like Lego or Nerf turrets, and eventually you can start to upgrade those to other types of turrets to identify threats to your home.
Lord.
Airsofting turrets.
Yeah, there we go. So one of the things that's interesting to me, and especially in like the traditional vulnerability research realm, which I don't engage a lot on, but like I sometimes wonder about how to generate what. So a little bit of background on machine learning side, the way you generate, and we'll say specifically for neural nets, because there are other forms of machine learning, but the one I'm most familiar with and one most people know about is neural nets. The way you create a neural net is you basically create feature vectors, and a feature vector might just be like one node takes the input from, I don't know, like a weight sensor. And so the weight sensor has a range of anywhere from like 1 ounce to 30 pounds. And that can be one feature in your feature input. And you might have thousands of features. And so when we take that and we apply it to like a binary, for example, you could have what branch was hit during the execution of a program, which means like, am I going to jump to this area of a program, or am I going to jump to that area of a program? And that set of like branch information and the order of that branch information could be a feature. How many branches did I hit could be another feature. What data did I access could be another feature. And when I say data, I mean like addresses in memory. What data? So all of these are different feature vectors, and then you define all of your feature vectors, and then you pipe it into this magical machine that outputs a model. And then you have to have your data set on one side that says this is what a valid program looks like, and this is what either an exploited program looks like, or this is what a vulnerable program looks like. One of your feature vectors could be like what function calls, like which standard library function calls does it make? Do I see any stir copies, for example? How many stir copies do I see? In what order do I see these things? And, how do you represent that as a feature vector is a whole different question. But from my perspective, I look at this area of, is it useful to apply machine learning to generate an AI system that maybe takes a binary in, or an execution of a binary in, which you have a trace from, and output the likelihood as to whether or not this thing has some form of vulnerability in it? And that vulnerability could be a simple null pointer dereference that causes the machine to crash, which could just be classified as a denial of service. Or it could be, I call a stir copy with an unvalidated input, and that causes a buffer overflow, which is, potentially actually gives you a way to inject into the system. And so I don't really think about the AI and ML portion. Like I'm not an expert in that area, but I know enough as to what data can I produce that may actually be useful. And I think this is where, when we were talking about Microsoft working towards a system that is able to detect these things, I think something like that is reasonable, but not in a kill decision scenario, right? Like, it's reasonable from the perspective of a developer to take their program, compile it, maybe with some amount of instrumentation, run it some number of times with some subsets of inputs or fuzzed inputs, and then take the output of those things, create feature vectors, and then pump it into a machine learning model and see what comes out the other side. If you do that on a large enough scale from the perspective of a corporation like Microsoft or Google or Apple, if you have tens of thousands of developers, if you have all of them pumping that data in constantly, I think a system like that very likely could find logic errors and find pretty, not easy to find bugs based on how execution maps are designed. I mean, there's other ways to implement the same thing, but I would be interested to see, and this would be exploratory research as to whether or not that's feasible. Now, that said, I have seen in my experience companies out there stating that they can do this and trying to sell a product that says it is working towards that end. And as someone who, again, I'm not an AI expert, but I do understand a little bit about the feature vectors that go into analyzing a program and what's reasonable and feasible, I'm just going to straight up call bullshit on it. Anyone who says they can develop a system that does that level of reasoning with any amount of accuracy is full of shit. And I say that because if you could produce a model that was capable of doing that, I can probably handcraft a program that defeats your model without really knowing all that much about it. And that's because if you could produce a model that could do that, you could functionally solve the halting problem.
Well,
right?
This in and of itself becomes, I want to answer two questions. First, I want to kind of talk about what you said, and then I want to split over because Gator asked about the question of like, what am I doing for it? And I think there's some interesting things. I think like one of the things you said is like, if you can create your own model against it, like this is how machine learning gets better, is you build two models and essentially fight them against each other. This is how like deep learning has been, or not deep learning, deep fakes have become so good, is because you train one model to create it and the other model to recognize it. And then you get to the point where this model is no longer recognizing the fake, and it improves this one. That being said, like, that is a remarkably, deep fake is remarkably simple in what it's doing. You're making one image look like another, like that very simple. What you're talking about is like levels of complexity, which is like what I was talking about with like web security. Like there's too many deviations. Now, I think outside of security, it could be really cool because then you could actually find where to put the money in development, because you would know which pieces are being used. But you don't necessarily need machine learning for that, because you can just look at analytics for that.
The example I like to use is someone taught an AI to play Tetris, and it was extraordinarily good at it. But at a certain point, it was about to lose, and it said pause, and then it did nothing. Like, it didn't continue playing the game. It didn't try and like start a new game, and it just stopped. It just paused, and it said like, I'm not losing. I'm not losing, therefore I'm winning.
I pulled a Joshua from the Whopper saying the best way to play is not to play at all. Or the best way to win the game is not to play at all.
So the piece I'm working on, and this is like the thing I am most excited about, and I think we're here. Like, I actually think you want to talk about cybersecurity, you want to talk about machine learning, artificial intelligence. Like right now, like a lot of like what Gowry's talking about is like cutting edge. Like we're not even like, we're exploratory. Like we're not even like there yet, and I would think we're ways off. But if we look at AI, like where are we succeeding right now? And you'd see like my smile because I'm getting excited about this. Is we're auto-driving cars. We're getting really close and things like that and whatnot. But the natural language processing, like, because we have tons of data on this already. Like, we have every book under the sun and things like that, but we're not necessarily teaching it, like, how to come up with unique content, even though it's been able to do that really well. But we've trained it using, like, Siri and things like this, which is, as I'm like worried I just have a device activated, we've trained it. In the two pieces to this, one, we've gotten really good with intents. Like, what is the intent of what I'm saying to activate this, and what am I asking? And then the natural voice has become amazing. You call into like some of like help desk or like any of these corporate lines, and you get someone who sounds like a human. And anyone who knows the video I just put out about social engineering knows, like, I think this legitimately is going to become so, okay, I'm going to say cool, terrifying probably the better state, but phishing attacks have recognizable like narratives. All of a sudden you can train an AI, natural language process machine learning, to figure out how to carry on a conversation. Not just like, here's the one-off shot, give me the information, but I'm going to carry on a conversation with this person back and forth over email to hundreds of thousands of people and conduct the full conversation and see how far I can get. And that could be over email, but what's terrifying is social engineering over the phone. Like in people go, oh, this is crazy. You can't do this. Like Google designed a system to order a pizza for you using this. It was online. It was free. This is not like you have to pay thousands of dollars to do this. You would tell it, order me a pizza from Domino's here, and it would call, it would ask them, it would pay, it could do all of those decisions. And so like we are at this point with social engineering, but here's I think the biggest problem, and this is why we haven't done it yet. You have people who understand AI and machine learning, and you have people in cybersecurity. And there's quite a few people here, but not a lot. And there's quite a few people here, but not a lot. And there's like what, 5 people in the overlap? Like and then those people, are they within offensive security? No, they're in like classification of data working at Microsoft, because so like maybe you have 0 people in this state where they care about offensive security within cybersecurity who have the knowledge here and have the knowledge here and can do it here.
Now, Gary had stated this a couple of times. I'm not an expert in AI. I'm not an expert in machine learning. I use it for practical applications. I've played with it for, I don't know, a better part of a decade, almost a decade and a half. And I don't understand all the underlying principles. I'm not an academic on it. And I just take the bits and pieces that I see that I need, and I implement them into real world scenarios. But as something I realized that some of my comments about the Nerf guns and the Lego guns were maybe a little off, that is also the AI that I've played with. I'm in the gaming industry. One of our goals is in first-person shooters is to make more realistic enemies that take vast amounts of data, process that data, and then come up with new strategies based off of what the other players are doing. If you have a bot or an NPC in a game, non-player character, that does the exact same thing the exact same way every single time, it is incredibly boring. But if you add some randomizations to it, and if you add a little bit of AI, not much because most systems don't have the processing power, but if you add in just a little bit of AI for that randomness, then you now have a more challenging, more interesting type game that you can play and you feel like you're fighting someone else. It's also why like multiplayer games became so popular. Is I'm no longer fighting against a machine that is now predictable. I'm now fighting against all these crazy ass humans that do random stupid things that just screw up whatever line of thought you have.
Is that why I'm horrible at Halo Infinite? Is that the reason why? Okay, all right.
Microsoft used their large amount of data to produce the best the best AIs in Halo Infinite. That's what it did. That's what it all was.
You know, the funniest part is there was that what was that? There was the movie on. It wasn't called Little Soldiers, Small Soldiers, Toy Soldiers, and it was
soldiers.
What was it?
Small soldiers.
Yeah, and it was on like taking the most advanced AI chip in the world, like which was made to put in missiles, and they put it in like small toys. I almost want to go back and watch that movie and see how well it aged, because it was just such a great concept.
Did it last
The movie's great.
Clearly need
to
do a react video for it.
Yeah, I was gonna say I haven't seen that movie in like a decade, but I do remember it being. I remember it being surprisingly violent, actually.
They had peaceful robots. Peaceful.
With that, thanks for if you've gotten to this point. Like again, I thank you so much for sticking around during some of the streaming issues. But I think we got them sorted out. I think we got them. Gator, how about you go ahead and start wrapping us up?
So just like any other tool that's out there, you can use AI ML for good or for bad. Don't always trust that the output is what you wanted. So, hey, make sure if you can, go play with it in open source land and see how it actually works so you can start becoming understanding of it. Past that, hey, go love your hacker family.
So I got a bunch of my background in information on this while I was in college, and so I had to do that was almost half a decade ago now, and I had to do some refreshers on this for the stream, and I do really recommend check out YouTube. MIT Open Courseware has some introductory talks about AI and machine learning that goes over a lot of this stuff and even more. And I think they even have like almost a full semester's worth of talks and classes up online for that. Super interesting to just put on in the background. If you have some exposure to it, I totally recommend going and taking a look at it. And you'll start to see this consistent distrust of the models throughout that is actually useful in assessing whether or not someone is, just spewing BS when they're trying to sell a product. So that's my sign off for today. Love your hacker family.
Do not fear Skynet. Fear the Skynet that I built.
With me is like, I think machine learning, artificial intelligence, it's so interesting. It's become so approachable. Like things like TensorFlow, JS, like you can build, like while Python has been like the love of this community, like you can build it in like Node, and it's so approachable. There's open source projects. Like I think it was like Fireside had a talk like in 120 seconds talking about how you can build your first machine learning. So I think there is a future for it. I don't know where it is in cybersecurity. Thanks for joining us, and hack on.